Polynomial function has the equation determine the zeros and a y-intercept if the following transformations are applied. Well, before the following transformations are applied, let's see what this polynomial looks like by itself. 1, 2, 3 x's, it's cubic. It has a positive leading coefficient, so it should have a shape that goes like this. Starts in the bottom left, goes to the top right. It should have x-intercepts at 4, -3, and -6. So curve shape roughly like so. And it's going to have a y-intercept. Well, the y-intercept happens when x is 0. If x is 0 up here, we get 0 minus 4 times 0 plus 3 times 0 plus 6, which comes out to -72. So our original expression goes through the points 4, 0, -3, 0, -6, 0, and the y-intercept 0, -72. Those are these three landmarks on the x-axis and this landmark on the y-axis. So now that we know that, what happens if we stretch it like this? Well, a -3 out front, outside the polynomial function, tells us that it's vertical transformations. This is a vertical reflection, as in top to bottom, and a vertical stretch by a factor of 3. What that does is any points that you originally had that were x, y are going to turn into x minus 3y. The x's do not change because vertical stuff does not affect x coordinates, and the y's get multiplied by -3. The minus represents the flip, the 3 represents the stretch. So what does that do to these points? If we originally had 4, 0, well, we keep the 4, and we do -3 times 0. That's kind of boring. If we do -3, 0, happens again. If we do -6, 0, this is becoming a bit of a trend. We keep the x-coordinate. We do 0 times -3, and nothing happens to the y-coordinate either. And finally, we get some activity on 0, -72. We keep the 0. -3 times -72 is 216. So the transformed version of this curve, after a vertical stretch, has all the same x-intercepts, but its y-coordinate, instead of being -72, is now plus 216. That makes sense if our curve is upside down and also 3 times higher than it used to be. If our curve looks like this. So this valley is 3 times deeper than the original. I should have drawn it a little bigger. This hill is 3 times taller than the original. That's probably about right. And these parts are 3 times steeper than the originals, but the x-intercepts have not moved. What about if we put a -1/2 x on there? Let's see what that does to us. We still have these same x and y intercepts to start with, but now the transformations we're getting are horizontal because these numbers are inside the function. This is a left to right reflection, or horizontal reflection, and this is a horizontal stretch by a factor of what? I hope you said 2. Remember, the horizontals are annoyingly backwards, so this actually means the x's will be twice as big when we're done. So our transformed points, if we had an original point that was x and y, afterwards, our y-coordinate is going to be exactly the same because horizontal stuff doesn't affect the y, but our x's are going to get multiplied by a -2. Negative because of the reflection, 2 because this is actually a factor of 2. So what does that do to these points? 4, 0 becomes -8, 0. -3, 0 becomes 6, 0. -6, 0 becomes 12, 0. And 0, -72, well, we go 0 times -2 is 0, and then we keep the -72. So this horizontal stuff changes all our x-coordinates, but does nothing to our y-coordinate. The new plot, let's see if I can fit it on here, would be -8, 0, and then it would have 6, 0, and twice as far out. 12, 0. Sorry, let's see if I can get those numbers out of the way. And our y-intercept has not changed. It's still at minus 72. So now we get a curve which still comes up through the same. Sorry, let's see here. If it's been reflected horizontally, then it should come up on this side. There we are. And peak. And drop down here. It's got a date with the x-intercept, y-intercept, sorry. And then it climbs up that way. So this red curve is the blue curve, only flipped left to right and much wider. The heights I tried to make exactly the same. So the height of this hill is the same. The depth of this valley is the same. But where this curve goes left to right, this other one is going right to left through those same features. It goes peak, valley, and up. So the x-coordinates are changed by horizontal transformations, but the y-coordinates are not. Horizontal stuff only affects your x's, vertical stuff only affects your y's.